everyone, my name is Kevin Gebertan and I am from grade 10 IPA. Today I will be talking about Newton's law of motion, and before we go into the law of motion, let's talk about the founder of the law of motion. So the founder was Sir Isaac Newton, and he was an English scientist and mathematician famous for his discovery of the law of gravity and also the three laws of motion. Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed unless it is acted upon by a force. This postulate is also known as the law of inertia. The law of inertia was first formulated by Galileo Galilei for horizontal motion on Earth and was later generalized by René Descartes. Sir Isaac Newton published the laws of motion on his book, which is called Philosophiae Naturalis Principia Mathematica, which basically means mathematic principles of natural philosophy in 16x. Today, these laws are known as Newton's laws of motion, and it describes the motion of all objects on the scale we experience in our everyday lives. First, we have Newton's first law of motion. The first law of motion, that is known as the law of inertia, states that an object at rest will stay at rest, and an object in motion will stay in motion at constant velocity, unless acted upon by an unbalanced force. What does that statement mean? It means that an object will keep doing what it was doing unless the object is acted upon by an unbalanced force. If the object was not moving, it will stay in the same state, and if it was moving at a constant velocity, it will keep moving. Inertia is the tendency of an object to resist changes in its velocity, whether in motion or motionless. Next, we have what is an unbalanced force. So, first, balanced force is the state where the forces on an object are equal and opposite. They are said to be balanced, and the object experiences no change in motion. Hence, the unbalanced force will happen if they are not equal and opposite. Then the forces are unbalanced and the motion of the object changes. We have a visual representation such as this. Just imagine that the force that each person gives is the same. 3 on the left side, 4 on the left side. That's unbalanced because it's a ratio of 3 to 4. It's not the same. If it's 4 to 4, then it's balanced. But I'll give a situation where it's balanced, such as this: 13 newtons on the left and 13 newtons on the right. This will make it balanced. But if the situation is like this, where 13 newtons on the left and 14 newtons on the right, then it will be an unbalanced force. Next, we have the example of Newton's first law of motion. So, we have a picture of a car crashing onto a wall with a dummy inside. The car was moving at constant velocity and was disrupted because it was acted upon an unbalanced force, which is the wall. The car crashed, and the dummy, which was originally laid back, was thrown forward against the seatbelt because the car was stopped by the wall, and the dummy would be launched. Next, we have a golf ball. The golf ball is sitting at rest on the tee, and the golf ball needs an unbalanced force to be able to change its motion. The unbalanced force is such as a hit from a golf stick. Next, we have Newton's second law of motion. Newton's second law of motion, or which we also call the law of acceleration, states that it refers to the net force of an object that is equal to the product of its mass and acceleration, or which we can call the equation, which is F equals to mass times acceleration. When mass in kilograms and acceleration is in meter per second squared, the unit of force is in newtons. 1 Newton is equal to the force required to accelerate 1 kilogram of mass at 1 meter per second squared. We have the equation, which is sigma F equals to ma. Sigma F means total, the F net, or the total force. M equals to mass. A equals to acceleration. Next, what is acceleration? Acceleration is measurement of how quickly an object is changing speed. Acceleration is the rate of change in velocity, refers to the change in velocity per unit of time, and force can cause motion only if it is met with an unbalanced force. Net force, or what we call F net, is the sum total and direction of all forces acting on an object. We have the equation. This is one from before. This means that acceleration is directly proportional to sigma F per mass, and sigma F equals to 0, which makes A equals to sigma F per mass, and sigma F equals to M times A. We have this equation. That's where it came from. And N equals to kilogram times meter per second quadrat. This is the unit of F. Next, what does F equals to M times A means? Force is directly proportional to mass and acceleration. If mass is increased in number and acceleration doesn't change, the force will increase accordingly to the mass. If acceleration is increased in number and mass doesn't change, the force will increase accordingly to the acceleration. I will give a representation such as this. If mass is increased in number, just think mass is become 2 times, and then acceleration doesn't change. A stays A. The force will increase accordingly to the mass force that is needed. Automatically, the force that is from the increased mass will be greater than the force from the object that the mass wasn't increased. Next, we have if acceleration is increased in number and mass doesn't change. Okay, acceleration is increased in number, mass stays the same, force increase accordingly to the acceleration. Now, moving 2 times the original acceleration, F equals to m times a, says that the box here will have force of the box when moving the original acceleration. So we'll have 2 times the force from the original box as well, because the acceleration increased. Next, we have problems to solve, such as this one. Object's mass equals to 2 kilograms. F1 is 5, F2 is 3, and then the magnitude and direction of the acceleration is F net equals to 5 minus 3, which becomes 2 Newton. And then we can use the equation A equals to sigma F per m, and A equals to 2 per 2. We have the sigma F2, and then we have the mass 2 kilograms. A equals to 1 meter per second to the power of 2. And then the direction will be to F1 because it's positive. Direction of the acceleration, direction of the net force, and direction of F. Next, we have a 40 kilogram block that is accelerated by a force of 200 newtons. Acceleration of the block is 3 meters per second squared. Determine the magnitude of friction force experienced by the block. We can use the equation sigma F equals to m per A. F minus Fg equals m times A. We have F, which is 200 newtons, and then Fg, we don't know Fg, we need to find Fg. M we know it, which is 40, and A is 3. 40 times 3 equals to 120, 200 minus Fg, Fg equals to 80 Newton. There we have it. Next, we have problems to solve as well. An object initially at rest on a smooth horizontal surface, a force of 16 Newton acts on the object, so the object accelerated at 2 meters per second squared. If the same object at rest on a rough horizontal surface, so the frictional force acts on the object is 2 Newton, then determine the acceleration of the object if the same force acts 16 and acts on the object. We know this one. So on the smooth surface, we can do it like this. Sigma F equals to m times A. We don't need to find sigma F again because we already know the force, which is 16 equals to m times A. A we got 2 meters per second squared. So 16 per 2 equals to 8 kilogram. We already have the mass. Now we go find the rough surface. We can do it like this. Sigma F equals to m times A. Use that equation again. And then F minus F of the friction equals to m times A. 16 minus 2, 14 equals to 88. A equals to 14 per 8. A equals to 1.75 meter per second. Next, we have more problems to solve. This one is easier. Some forces act on an object with mass of 20 kilograms, as shown as figure below. Okay, the mass is 20 kilograms. 20 kilograms. So we can just 15 minus 15, 25, 30, 40. We have 40. We have the sigma F from 25 plus 30 minus 15. 40 per 20 kilogram equals to 2 N per kilogram. A equals to 2 meter per second squared. Next, we have Newton's third law of motion. Newton's third law of motion, or as known as law of interaction, states that each action brings an equal and opposite reaction, which basically means for every force acting on an object, there is an equal force acting down in your seat. But Newton's third law says your seat is pushing up against you with equal force. This is why you are not moving. There is a balanced force acting on you, or we can say gravity pulling down, and then your seat pushing up. The same applies to when you hit the wall with your hands. The wall will apply back the same amount of force to your hands. From that, we can conclude that F action equals to F reaction. This we have the visual representation. Oops. So when the weight pulling down by the gravity, this chair pushing up against us. Next, we have examples of the law of motion. What happens if you push yourself against the wall with your legs while sitting on an office chair? The wall will gain action, which is from the legs, and releases back the same amount of force that is applied to the wall back as a reaction, and you will be pushed away against the wall. Next, second example. Why does it hurt a lot when you hit your toe against the corner of the desk? Because before we hit it, we subconsciously give same force applied when we walk normally. And the force when our toe hits the corner of the desk will be applied to our toe back as a reaction from the corner of the desk. And the more force applied, the more our toe will hurt. Next example. Consider the motion of a car on the way to school. So a car is equipped with wheels which spins backwards. As the wheel spins backwards, they grip the road and push the road backwards. Next example of third law of motion. The reaction of a rocket in an application of the third law of motion. Various fuels are burned in the engine, producing hot gases. The hot gases push against inside the tube of the rocket and escape out the bottom of the tube. As the gas moves downward, the rocket moves in the opposite direction. Next, we have problems to solve. Dave is riding his skateboard and pushes off the ground with his foot. This causes him to accelerate at a rate of 4 meters per second squared. Dave weighs 509 Newton. How strong was he pushed off the ground? So, we know that Dave weighs 500. We know that he weighs 589 Newton, and he accelerates at 4 meters per second squared. The gravity is 9.81. Okay, so what we can search for is the W, which his real mass without the Newton. Okay, we can use this weight 559 Newton divided by the gravity. this equals to 60.0 kilogram. So next, we can now find how strong he was pushing off the ground. So where's the pointer? F equals to m times a. We use this equation again. Then we know the m now, 60. Sorry, this is m. 60 times a. The acceleration was 4. Then we get 240 Newton. Okay, we have the last problem to solve. There are two men which are having a solving contest. Each man pushes the other at the exact time. Ross pushes Jake with 90.4 Newton, and then Ross pushed him with 110.2 Newton, 90.4. So we can use the third law of motion to solve this, where he asked how much force is exerted on Jake. Okay, Jake, they push each other. So Jake was pushed by Ross with the amount of 110.2 Newton of force. But we need to remember, the force that is applied will be applied back to us, which is 90.4 Newton. This will amount to 200.6 Newton. Thank you for listening to my presentation. Thank you.